Hi there. In this video, we are tasked to solve for x in the equation the square root of x plus 23 minus 10 times the square root of x minus 2 plus the square root of x plus 34 plus 12 times the square root of x minus 2 equals 11. Before we solve this one, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So to solve this one, what we can first do is, because it's not really nice to have a radical inside a radical, we can let y to be the square root of x minus 2. So we do this to remove this one out here. And from this, we can obtain x out here. So starting by squaring this one, we'll get y squared equals x minus 2. Then, adding to both sides, we'll get x equals y squared plus 2. So, we'll be using these two out here to solve this equation. So, plugging in these values in our equation, we'll obtain this. So, basically, we replaced x out here with y squared plus 2. Then we replace the square root of x minus 2 out here with y. And the same goes for this other radical out here. Then simplifying these expressions, so we can add 2 and 23 out here. So that will be 25. And 2 and 34 out here. So that will be 36. So we'll have that one. And from here, take note that these expressions inside are actually perfect square trinomials. So by our knowledge on perfect square trinomials, so let's write it down here. If we have a squared plus minus 2ab plus b squared, this factors into a plus minus b with a square outside. So doing the same for this one, so take note that this one in the middle is the 10 out here is equal to 2 times 5. This one is equal to 5 squared. This one is equal to y squared there. This one out here is equal to 2 times 6. And this one out here is equal to 6 squared. There. So given these values, we can get, or we can apply the perfect square trinomial factoring. That is, we'll get y minus 5 squared inside and y plus 6 squared inside. So I hope you got that one correctly, or you understand that one properly. And now, observe here that since we know that the square root out here just means that we have an exponent of 1/2, then we can cancel out the radical and the exponents or the square inside. So that is, we'll have this. And so we'll be left with the absolute value of y minus 5 plus the absolute value of y plus 6 equals 11. Take note that the absolute value out here is important, since when we get the square root of, say, x squared, what we get is not only x, but rather its absolute value. So take note of that one. And now let's clear out some space so that we can focus on this one. So let's have this and move this up. There. And now, what we'll be doing next is we'll be solving this absolute value equation, wherein we have two absolute values out here. So this one is quite tricky, especially if you don't know how to do this. So I'll probably link a video explaining how to solve absolute value equations involving two absolute values. So by this time, you probably have checked that one out, but if not, I'll try to explain how it worked out here. So in here, when solving absolute value equations, the first thing to take note is the critical points, or that is, these are the points that make the expression inside the absolute value to be 0. So in this case, a critical point is 5, since 5 minus 5 is equal to 0, and in here a critical point is negative 6. So we plug in these values to a number line out here, and these critical points will serve as a divider on the regions that we consider in absolute value equations. So it's like we divide this out here and out here. So the first region would consist of values less than negative 6. So y less than negative 6. Then in between here we have y from negative 6 to 5. And lastly we have y to be greater than or equal to 5. But take note that y out here is equal to the square root of x minus 2. And since this one is a radical, we know that this must be greater than or equal to 0. Since we know that radical values always have a positive outcome. So we'll only consider values greater than 0 out here. Or that is, we'll consider only this part. So these two are the regions that we'll be needing in solving this absolute value equation. So let's move this one up here. And let's focus first on the first region. So we have this. So on y from 0 to 5, the absolute value equation would become this one. Take note that the important thing here is that this first out here, we need to put a negative out here. The reason for that is because if we take values in this region, the outcome out here would be negative. But since we know that the outcome in the absolute value must always be positive, we need to multiply a negative to make it positive. So I hope that one is clear. And let's focus on this equation. So starting by distributing this negative sign out here, we'll get negative y plus 5 plus y plus 6 equals 11. Observe that we can subtract the y's out here, and adding the 5 and 6, we obtain 11 equals 11. We know that 11 equals 11 is always true or always valid. This means that for any values of y in this region, we'll have a valid equality. Therefore, the solution for this region is the whole interval, which is y from 0, included 0 until 5, but 5 is not included. So let's take note of that one. So let's clear this one and move this one out. Next, we consider this next region. So we have on y greater than or equal to 5. So in this region, the absolute value equation becomes y minus 5 plus y plus 6. So we don't need to change anything in the expression inside, since for taking values in this region would result to a positive outcome already. So we just copy the expressions inside. So simplifying this, we can add the y's and the constants to get 2y plus 1 equals 11. Move 1 to the right and we get, so 11 minus 1, that would be 10. Divide to both sides and this gives us y equals 5. This means that on this region, y equals 5 is a solution as well. So combining this result as well as what we obtained earlier, we can conclude that the solutions for our absolute value equation are y in the interval 0 to 5, wherein both 0 and 5 is included. So now that we have, or we know the solutions or values possible for y, we can go back now to what we really want, which is the x. So going back to the square root of x minus 2, since again y is equal to square root of x minus 2. So we know that the square root of x minus 2 is in this interval. So solving for x we can have this one. So I just have written it in this form. Then we can start by squaring every part of this inequality. So we'll get 0, or x minus 2 is from 0 to 25. Take note that we squared this one to remove the radical. Then, since we want to obtain x, we can add 2 in all sides of the inequality to get x from 2 to 27. So, given this one, we can now conclude that the solutions for this equation is given by x in the interval from 2 to 27, with both 2 and 27 included. And this out here is our final answer. So did you got that one correctly? I hope you did. The key again is to start by letting y to be equal to square root of x minus 2. Since from that, we can obtain and simplify this equation out here. From then, you'll need some concept on perfect square trinomials or square of binomials, as well as the concept on radical, that when we get the square root of a square, we get its absolute value. After that, since we'll have an absolute value, we'll be dealing with absolute value equations, so you also need some knowledge regarding that. And the rest of this, upon obtaining y, is quite straightforward. So yeah, that's it. I hope you enjoyed and learned a lot from this one. Feel free to comment down below any suggestions and recommendations that you have for this video, as well as this channel in general. So yeah, that's it, and that's all for this how to solve video.